Okay, here we have section 1.4, which deals with angle measures. So our main ideas, measure and classify angles, and then identify and use congruent angles, and the bisector of an angle, and a whole host of new vocab words. So you can see those right there. Okay, so to start, definition of a degree. So a degree is 1/360th of the way around a circle, so that makes there be 360 degrees in a circle. A ray is part of a line, so it has one endpoint and extends indefinitely in one direction. So it's kind of a cross between a line and a segment. It has a one definite end and one part that goes on forever. Rays are always, though, named using the starting endpoint first and then any other point on the ray. So this ray down here you can name as either EF or EG. Those are the only two names possible. Also, if you look at the symbol, so since this is a ray, it has one endpoint and one part that goes on forever. The order you name a ray also matters. E is the endpoint, so it has to come first, below the endpoint part. So angle measure, so if you pick any point on a line, that point determines two rays called opposite rays. So here, I'll use point P here. So point P, there's two rays coming from P. Oops. There's PR, there's also PQ. So even though, that looks like a G, PQ. So even though this ray, for example, runs left, you still endpoint, point that keeps going. The order is always that way. Okay, just some more definition type stuff. So an angle is formed by two non-collinear rays, meaning they aren't on the same line. So that previous example, those were collinear, so they don't actually form an angle. The rays themselves are called the sides, and the common endpoint is called the vertex. So you can kind of see here, this is angle here, so it's angle ABC. Actually, it's not angle ABC. It's angle A, or it's angle BAC, or angle CAB, or angle, looks like there's a 4 in there, angle 4. All of those would be possible answers. So angle BAC, angle CAB, angle A, or angle 4. If you notice, when you use all three letters, the vertex always goes in the middle. So the middle letter of an angle is the point of the angle. And there's a key concept that can go in your book. So if you have an angle, it divides things into two parts. You have the interior and the exterior. So in this example, A, D, and E lie on the angle. They're actually on the rays. C and B are in the interior, the more closed-in part of the ray, or angle. And D, or F, and G lie in the exterior, the outside. So an angle always describes an interior and an exterior. The interior is always the smaller distance around. The exterior is always the larger distance around. Okay, so example 1 here. Name all angles that have W as a vertex. So there is W. So let's see here. We've got angle XWZ. You've got angle XWY. You've got angle 1, angle 3, angle 2. So you've got angle YWV. So XWZ, XWY, Y. You got angle, we already got those. You can go those backwards as well. You also have ZWX, YWX, VWY in addition. So the sides of angle 1, so we'll call that part A. So part B, the sides of angle 1 are ray WX and ray WZ. And then C, write another name for angle WYZ, so that's that angle. That is angle 4. Okay, angle measures. So you can classify angles by their measures. So for some angle A, you have a right angle if it's exactly 90 degrees, an acute angle if it's less than 90, and an obtuse angle if it's between 90 and 180. And that's also what that illustrates down there. So example 2 here. Classify each angle as right, acute, or obtuse. So to begin with, PMQ, this angle is less than 90 degrees, so it is acute. TNQ, MR is actually a right angle. If you notice, there's a lovely little square there. That's the right angle symbol. Okay, so just as segments that have the same measure are congruent, the same thing is true for angles. If two angles have the same measure, they are congruent angles. Alright, example 3. So a trellis is used to provide frame for vining plants. Some of the angles formed by the slats of the trellis are congruent angles. In the figure, angle ABC and angle DBF are congruent. If ABC is 6x plus 2 and DBF is 8x minus 14, find the actual measures. So since it tells you they are congruent, just like with segments, congruent things are always equal to each other. So I can move the 8x over. So it's negative 2x plus 2 equals negative 14. Move the 2 over. Oh, off the screen. Negative 2x equals negative 16. Divided by negative 2, so x is 8. But that's not the answer. It wants the actual measures, so I have to go back up. So 6 times 8 plus 2 is 48 plus 2, which is 50. Or I could do the other one, 8 times 8 minus 14. That's 64 minus 14. That is also 50. So the angles are each 50. And lastly here, so angle bisector, just like a segment bisector. So any ray that divides an angle into two congruent things is called the angle bisector. Segment could also be a bisector. So when a line divides an angle into smaller angles, the sum of the measures of the angles equals the measure of the largest angle. So if you add the two parts together, you get the whole back. And that's the end of the section.